All right. So, I don't think I really need to show the slides for this one. This is a bunch of formulas. Luckily, for the next test, I have a formula sheet. I probably have it posted. I don't think I brought it with me.
Yeah, she's not good check.
You don't have to memorize these formulas.
Right? Good.
Formula sheets are my best friend.
Okay, you do need to know, the Pythagorean identities and the 1 over, cosecant is 1 over sine and all that. You need to know that stuff, but you don't need to memorize this. So here's the difference of two angles formula. It's cosine, if you got cosine of alpha minus angle beta, it will be cosine of alpha times cosine of beta plus sine of alpha sine of beta. Don't you love these big letters?
I really like regular letters.
I never thought that numbers and letters should ever mix. Oh well.
Oh well. Well, they do if you're in this high math class. I know some people. Why did we put numbers and letters together? Never put Greek letters in there. What the heck? Okay.
No letters went in.
And the proof, I have 634 written on my paper, but I don't even know if that's right. But they have a proof of this. You can look at that. It's a good idea to read the book, but I'm not going to make you prove that. You want me to have you prove it? No. Okay. So we're going to just use that formula. So can you use the formula you're given? So let's use it to find cosine of 30. That is kind of a silly problem because we all know what cosine of 30 degrees is, but we're gonna use this half angle formula. Cosine of 30 is the square root of 3 over 2 if you look on a unit circle. So why we do this? Well, we're just showing you that this works. If we rewrite 30 as cosine of 90 degrees minus 60 degrees. So this is going to be our alpha, and this is our beta. So we're just going to write it down, cosine of 90 degrees, cosine of alpha, cosine of beta, 60, plus sine of alpha, that's 90, sine of beta, 60. Okay. Well, so this is kind of a silly example, but if you're up at 90 degrees on the unit circle, here's a sketch of the unit circle. 0, 1. Cosine of 90 degrees is 0. Cosine of 60 degrees, that's the short side, is a half. I wrote 1/2 on my paper, but I put 0.5 here. Okay, and guess what? Sine of 90 is 1, and then sine of 60 is square root of 3 over 2. But this actually does work. This cancels. 0 times anything is 0, and you get the square root of 3 over 2. So we should already know what cosine of 30 degrees is. So this is just showing that this formula works. Now this next one, we don't know what cosine of 15 degrees is, so this is a better example. You got to figure out how to subtract two angles and get 15 degrees and use angles that you know sines and cosines for, or can look up on the unit circle. So if you use 45 degrees minus 30 to 45 minus 30 degrees, that works, okay? And you get 15. So cosine of 45 degrees, cosine, of course, this is our alpha and beta. And if I didn't have the formula written right up here, I would be rewriting the formula right above my work. Just to make sure I don't make any mistakes. So, but I still, so cosine of 30 plus sine of 45, sine of 30. Okay, here's our 30-degree angle. This side is a half on the unit circle, that's 1. And this is square root of 3 over 2. Dr. McMillan. Oh, this is my dentist. I can say. Hello? Yeah. I broke a tooth on Friday, and I had to have a crown. I've got a temporary crown that I had put on yesterday, so they were calling to see how I was doing. That's really nice, but...
I wish my dentist did that. They don't even call and tell me when I have appointments.
Oh, they don't? Well, I go to Dr. McMillan Bristol if you want to switch.
That guy's only open like 2 days a week now.
Oh, wow.
So when I miss my appointment, I have to wait like another 2 months before I can actually go.
Uh-oh.
But I've been going to him for years, so I like consistency.
Okay, so cosine of 45 is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Adjacent over hypotenuse. This is 30 degrees. So I sketched that so I could remember these. Sine 45, I know, is square root of 2 over 2. Sine of 30 then is 1/2. I'll just write it as 1/2 instead of 0.5. Okay, so, and then you're going to multiply. Now this is where, you know, you in this class, you still need to know algebra. So when you multiply this, if you take the square, I'll write it over here. If you have the square root of A times the square root of B, you can combine them under one square root. That's what we're going to do. Remember, when you multiply fractions, you do the top times the top, the bottom times the bottom. So we get the square root of 6 over 4, and I'm running out of room, plus square root of 2 over 4. Okay, can you see that? Square root of 6 over 4 plus the square root of 2 over 4, and that equals the square root of 6 plus the square root of 2, and that's all over 4. We have a common denominator. We have a common denominator, so we add the numerators and keep the denominator. Okay, so, and does the square root of 6 combine with the square root of 2 and make the square root of 8?
No.
No. They have to be like radicals to combine. You have to, it has to be the same number under the square root. So if this was 3 times the square root of 2, then we could say that's 4 square root of 2. You combine them, but you can't combine the plus sign. You have a plus sign here. You can only use this if you're multiplying, where you put, and we use that right here. Right here. Okay? So, and in this class, I want exact answers with square roots. I don't want the I may ask for the decimal approximation of 2, but you need to give me this exact answer with square roots. So this is the answer. That's what it says, find the exact value. We're finding exact values. All right, the next one, find the exact value of this. This is just the formula work backwards. Look at the formula up here. If you make 70 degrees alpha and 40 degrees beta, this is the same formula. It's going to be equal to cosine of alpha minus beta, which is cosine of 70 degrees minus 40 degrees, which is cosine of 30 degrees. And we can find that on the unit circle, square root of 3 over 2. Well, we should be able to find that without our unit circle too. Okay? Alright, another one, we're working backwards. But now, these were degrees, this is in radians. We can see those pi's. Find the exact value. So here's our alpha. Here's our beta. We have two cosines multiplied together and two sines multiplied together. This is alpha and beta. So this is cosine of alpha minus beta is cosine of 5 pi over 12 minus pi over 12 is cosine of 4 pi over 12 is cosine of pi over 3. Oh, wait a minute, we have to find that. What's that, 60 degrees?
Yeah.
So that is 1/2. Sorry. That's not the answer. We actually get an answer of 1/2. Yeah, and I wrote on my filled in notes that pi over 3 is 60 degrees. That was one of the ones you should have memorized to go back and forth between those. Or be able to figure out pretty quickly. Okay, and then we're going to do verifying an identity using the difference of cosine formula. Okay, so here's our identity, right here. This is cosine alpha, cosine beta in the denominator. It's just, I need to go back and fix these notes, but I haven't had time to do that. So, all right, so we're going to use the cosine formula. So we're going to verify that this equals that. So we're going to start with the left side of the equation. We're going to rewrite cosine of alpha minus beta with the formula. So it's cosine of alpha times cosine of beta plus sine of alpha sine of beta. And then that's going to be divided by this, but we can separate that. When you're dividing two terms by the same numbers, you can separate it. And that's what I'm going to do. I'm kind of skipping a step here. Cosine of alpha, cosine of beta. We can separate our fractions. You got to look back and review your rules of fractions. Struggle with this if you don't. Okay, and what is this? 1. And tangent is sine over cosine. So this is tangent alpha, tangent beta. and it's verified. Any questions? This was the same thing over itself. Did you want to see the step I skipped? Did you understand how I switched it? Or did you need to see that? No? Okay. I skipped that step on the filled in notes. Okay, and then we have the sum and difference formulas for cosines and sines. Okay, and you could open up the slides if you want and show me or something and fill these out too, but these are just a cosine of a sum of two angles is cosine of the first angle times cosine of the second minus sine, the two sines. And you could get that from the first formula by the fact that sine is an odd function. Cosine of alpha minus beta, that's the one we already wrote down, right? Cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. What's the sine of two numbers added to get two angles added together? Sine alpha cosine beta plus cosine alpha sine beta. And then if you're subtracting them, you can just rewrite this as alpha plus negative beta. And when you put in a negative beta here, you're going to make it positive by bringing the negative sign out front. It's just what we had up here with the minus sign. Okay, so you don't have to memorize these formulas though, but you do need to know how to use them. So find the exact value of sine of 5 pi over 12 using the fact that 5 pi over 12 equals pi over 6 plus pi over 4 in the correct sine formula. So we're going to find the sine of 5 pi over 12 is the sine of pi over 6 plus pi over 4. That formula up here, let's move it down just a little bit, there we go. We're just gonna do that. This is our alpha, this is our beta. So that's gonna be sine of our alpha, pi over 6, or maybe we just want to write sine, cosine, plus cosine, leave a spot, sine, and fill these in. Cosine of pi over 4, pi over 6, pi over 4. Okay, sine of pi over 6, that's the 30-degree angle, is 1/2. Cosine of pi over 4 is the square root of 2 over 2, that's 45 degrees. Cosine of pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. This works out the exact same way that other one we did on the first page worked. It's square root of 2 over 4 plus the square root of 6 over 4. Then you combine those at the same fraction. Here's your exact answer. Okay. All right. Now we're going to do the next one. We're getting a little trickier now, but I mean, have you seen things like this before? Find an exact value. If sine of alpha is 4/5 for quadrant 2 angle alpha, and sine of beta is 1/2. Okay, so we have two angles. This is our alpha, this is our beta. Sometimes it's hard to see that alpha. Find the exact value first. We're going to use this information to find all three parts. This is like a worksheet I have for you. So we're going to draw a sketch. So if this is a quadrant 2 angle, then we're going to make this be alpha. This is alpha. We have to remember reference triangles from the first section, right? You draw it down to the x-axis. That's our reference triangle. This is alpha. This in here would be our reference angle, so say alpha prime or something. Sine of alpha will be the same as sine of alpha prime. So sine is opposite over hypotenuse. So we have a 4 here and a 5 here. So the opposite is 4, the hypotenuse is 5. You're not drawing it on the unit circle because you're given opposite over hypotenuse. Okay, now we have a right triangle. We can find this other side. I called it X. This side. Find that side. So this is our alpha, and we're not even using beta in this problem yet. Okay? The part A asks for the exact value of cosine alpha. So you need to find X. So you're going to use the Pythagorean theorem. Anytime you have a right triangle and you have two sides, you can find the third side by taking the squared, the leg squared added together equals the hypotenuse squared. And that's x squared plus 16 equals 25. Subtract the 16. X squared equals 9. So x equals, you take the square root. Is x going to be positive 3 or negative 3 in quadrant 2? Negative. So x is going to be negative 3. So you're going to take the square root of both sides, and because of where it is, we're going to use the negative one, not the positive one. So x is negative 3. Now we can find cosine of alpha is adjacent over hypotenuse, and that is minus 3 over 5. And these are the kind of steps I want to see. Okay, does that make sense? So this is this is what we've already done. So we're building on what we've already done. You still need to know everything from chapter 4 when we're in chapter 5. So now we're going to find the exact value of cosine beta. So it says sine beta is 1/2 for a quadrant 1 angle beta. So it tells you beta is in quadrant 1. They're being nice to you here. On this example, where it was a 3, 4, 5 triangle, and it didn't have the square root. But now this one's going to have, if you're in quadrant 1, and sine of beta is 1/2. Sine is it's opposite over hypotenuse again. So we'll draw that. Yeah. Here's our beta, and this is opposite over hypotenuse. And this is going to be square root of 3. So, or you can find it. You can let x be that side. X squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. X equals, subtract the 1, 3. X squared equals 3. And the square root, and it's going to be positive because it's in first quadrant, it's going to be x equals square root of 3. So, what's the value of cosine beta then? Cosine beta is adjacent over hypotenuse, and that's the square root of 3 over 2. In fact, this is one of those triangles you were supposed to memorize back in the first section. This is the standard 30, 60, 90 triangle. So if I ask you a question that's a standard 30, 60, 90, you wouldn't have to show this stuff. I'm showing it to you in case you don't remember that. Okay, so does that make sense? So we found cosine of alpha, and we found cosine of beta. Now we're going to be on the new stuff. Find the exact value of cosine alpha plus beta. So we're stepping you through it. You have to find this first, and then that, and then you're going to use the angle formula up there. And since it's way up at the top of my page, I'll write it again. Cosine of alpha plus beta equals cosine of alpha cosine beta minus sine alpha sine beta okay, our alpha. So is alpha negative 3/5? No, it's cosine of alpha is negative 3/5. Some people last year did this, but this you substitute is negative 3/5. Cosine of beta is the square root of 3 over 2. The cosine's no longer there, folks. Okay? We know cosine of beta is this. So we're substituting. And then we're subtracting sine. Well, we were given sine of alpha was 4/5 up here. This is 4/5. Sine of beta was 1/2. So you have to drop the cosines and the sines now. Don't say that this is cosine of minus 3/5 times cosine of square root of 3 over 2. You know. Okay? That's just a common mistake. Now we're going to multiply minus 3 square root of 3 over 10 multiply a fraction, minus 4 over 10. So we're going to write that. Here's the exact value. Okay, so, and that's the exact value. You can't combine the terms in the numerator. You can't all of a sudden put parentheses here and make this minus sign be acting on both things. The minus sign is only acting on this term. You don't have to factor the minus sign out. This is it. This is the answer. Okay. Any questions? All right, this is part D of the same problem. So we're on the next page in the same problem, unfortunately. So sine of alpha plus beta, so you write down what that is. Sine is a sine times a cosine plus a cosine times a sine. And that's alpha, beta, alpha, beta. So, from the previous page, maybe I'll just write all these values up here. From the previous page, we know that sine of alpha was 4/5. We know cosine of alpha was minus 3/5. We know that cosine of beta was the square root of 3 over 2, and sine of beta was given to us as 1/2. So we're going to, these are from the previous page, we're going to plug these in. 4/5 times square root of 3 over 2 plus minus 3/5 times 1/2. Okay. 4 times the square root of 3 over 10 minus 3. That's our answer. So the hard part was figuring out parts A and B. And you're not always going to be given a 3, 4, 5 triangle or a 30-degree angle. All right, and then the sum and difference formulas for tangent are given here. Tangent of alpha plus tangent of beta divided by 1 minus tangent alpha tangent beta. And then if you're subtracting, just rewrite this as alpha plus a negative beta. Tangent is odd, so it's going to change the signs. You're going to have the same thing as above, but we're going to pull the minus sign out. Minus tangent beta and 1 plus tangent alpha tangent beta. We're using the fact that tangent is odd. These two formulas you can easily find this one from that one. All right, and we're going to verify an identity then with this. Okay, we're going to show that tangent of x plus pi is the same as tangent of x. So we're going to plug that in into this formula up here. Here's our alpha. Here's our beta. Our beta is pi. We're going to go ahead and write that out. It's tangent of alpha, which we're using x, plus tangent of beta, that's pi, divided by 1 minus tangent of alpha, well, that's x, times tangent of beta, that's our pi. Okay, if you sketch the unit circle, at pi radians, you have -1, 0, and tangent, so tangent of pi is sine of pi over cosine of pi. That's y over x. That's 0 over -1 is 0. So we get tangent of x plus 0 divided by 1 minus tangent of x times 0. Anything times 0, you know, this is 0 is not inside the tangent. Is anything times 0 is 0, and so you're going to have tangent of x over 1 or tangent of x. Okay, so you'll have to use these different formulas in order to memorize them. So we need to start 5-3. Any questions? Five, 3. If you didn't print them out, you better print them out pretty quick. Okay, so we can find these double angle formulas from the previous formulas. But what you need to be able to do is just use them. So sine of 2 theta is 2 times sine of theta cosine theta. Cosine of 2 theta is cosine squared theta minus sine squared theta. Tangent of 2 theta is 2 tangent theta divided by 1 minus tangent squared theta. So you're going to find the exact value of sine 2 theta using the double angle identity. It's sine theta. Okay, so this is part A. That was confusing me, that little A in there is part A. This is part B. Part C, but we're going to use we're going to use the double angle identity. So you do have to follow the instructions. If sine of theta is 4/5 and theta lies in quadrant 2. Okay, this is the same angle we drew before. Actually, I guess it goes up like this. 4/5. This is our theta. And this is -3. We found it before. Right? On the first, other section. Okay, that's our theta. This is our theta prime, the reference angle. This is a 90-degree angle. Okay, so if that's the picture, That's quadrant 2. So now we're going to find sine of 2 theta using our formula. Sine of 2 theta would be over here, maybe in quadrant 4 or somewhere over there, but we can't draw the triangle for 2 theta. We're going to use the fact that we know all this information. It's twice sine theta cosine theta. So let's write down what sine theta and cosine. Well, we already know sine theta. So sine theta, this cut off at a bad point. Sine theta is 4/5. And cosine theta was minus 3/5. And that gives you 2 times 4 is 8 times minus 3 is minus 24. 5 times 5 is 25. And I do want you to leave that as a fraction, not as a decimal, and show your work. On the filled-in notes, I guess I showed my work for finding this -3. But we did it on the previous page. So then it asks us to find cosine of 2 theta. We're going to use this formula. It equals cosine squared theta minus sine squared theta. Cosine squared theta is cosine theta is minus 3/5. So we're going to square that. Sine theta was 4/5. And we're 4/5. And we're squaring that. So you square a fraction by squaring both the numerator and the denominator. You get 9 over 25 minus 16 over 25. And that is minus 7 over 25. Is this making sense? No? You just show. Okay, so you're using these things, you're still having to use the stuff we learned in the test 1 material. Tangent of 2 theta. Well, tangent of theta, we can find tangent of theta. We're going to need to know tangent of theta. This is not 2 theta. Tangent is sine theta over cosine theta. Or we could, we want to use the double angle identity, so I'm going to use the double angle identity to find tangent of theta, tangent of 2 theta. So tangent of theta is sine over cosine. Sine of theta was 4/5. Cosine was minus 3/5. So if you get a fraction over a fraction, you can write it as 4/5 times, and you flip the second one. Yes, and the 5's cancel. If you understand that, then you're going to get 4 over minus 3. So you can skip this step if you understand that if you have a fraction over a fraction and the denominators are the same, they will cancel out and you're going to be left with 4 over minus 3. Only skip this step if you understand that. It's a trick, but I've had people then I show them this, and then they have something like this, and they're canceling out something. Or have, if this was a 5, you know, it has to be a fraction over a fraction. If you don't understand this, then definitely write this out. Okay, so that's tangent, and you can move that minus sign anywhere you want. So we're going to use the double angle formula to find tangent of 2 theta. It's 2 times tangent theta divided by 1 minus tangent squared theta. And that is 2 times minus 4/3 divided by 1 minus 4/3 squared. 2 times minus 4/3 is minus 8/3. And then you're going to square this. So it's 1 minus 16 over 9. The negative sign is squared, so it's positive then, but this negative sign is still there. Then you're going to rewrite 1 as 9 over 9. And 9 minus 16 is negative 7. So you get minus 8/3 over negative 7/9. You can't cancel that, so you're going to rewrite it as minus 8/3 times, and flip this fraction, 9/7, and it was also negative. The 2 negatives cancel out. Does anything cancel? Before we multiply, we can cancel. You can use your calculator to help you with the calculator part. We're going to divide by 3. Divide by 3. Nothing else cancels. Negative 24 over 7. That's our answer. Does that, oh, positive. The negative signs cancel out. Does that make sense? Look, we could have just found it by taking sine of 2 theta over cosine of 2 theta. If you put this over this, the 25s cancel out, and you're left with 24 over 7. So our double angle formula worked. Do you guys see that? Why that works? You could have done, I'll do it right here. Tangent of 2 theta equals sine of 2 theta divided by cosine of 2 theta. And that is minus 24 over 25. I don't like writing fractions that way, but and minus 7 over 25. You can flip it and cancel, flip the second fraction, but that is 24/7. So that's the other way to get that. You got the same answer both ways. Okay. Any questions? Are you awake?
Fall asleep.
Oh, no. Okay, so find the exact value of cosine squared of 15 degrees minus sine squared of 15. So you have your formula sheet. You better be looking at your formula sheet to see which formula this is. Look up here, that one, but you have formulas, a lot more formulas. So we're going to use the fact that cosine of 2 theta equals cosine squared of theta minus sine squared of theta. So our theta is 15 degrees. So what does this equal? It equals cosine of 2 times 15 degrees. It equals cosine of 30 degrees, and we know cosine of 30 degrees, we can draw the standard triangle. If this is 30 degrees, this is the short side. If you make that 1, it's half the hypotenuse, and this will be square root of 3. And so that is cosine is adjacent, yeah, over hypotenuse. Square root of 3 over 2. We're always finding exact values. All right, and then some more formulas. One teacher told me that her high school class used to have to memorize all these formulas. But you get a formula sheet, you just need to know how to use these formulas. So cosine squared theta minus sine squared theta. 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. These are all cosine up to theta. You can use the fact that sine squared theta plus cosine squared theta equals 1 to manipulate between these and get these other ones. You know, we're using this to get between them. But okay, so we're going to verify an identity. We're on page number 7. So just a note, registration opens for fall and summer this Monday. So you're supposed to be having appointments with your advisors, or I've got an email about when the Advising Resource Center is going to have some open sessions next week in the Humanities Building, I believe. I can post that in Showbeat. Okay, if you didn't get advised, you do have to be advised, or you can't register. It does. You have to be cleared. There's not a special code anymore.
That's really disappointing.
Yeah. Anyway, that's what they've done. It makes it harder for us too, but it's to try to keep you from taking the wrong class, or to not take a class. Some classes, especially in engineering, are only offered in the fall or the spring one time. And if you are supposed to take it in the fall and you don't, you gotta wait a whole year to take it then. So that's why you get advised. But okay, so we're going to verify this identity here. This is a little bit long, so this will be
Your time to finish this one.
yeah, what? Do you want to quit?
I mean, I'm just looking at the filled in notes and it looks like it's more than 8 minutes.
Yeah, it does look like it's more than 8 minutes. Look at the filled in notes. I'll tell you what. Yeah, I'm kind of getting tired of doing this. Look at the filled in notes and see if they make sense. And we'll start at 9 next time. Look at 7 and 8. Try to do them yourselves.
But come Monday or Tuesday or whatever, you're gonna be ready to do 7 and 8.
Yeah, well, we could do. Okay, on Tuesday we will cover the rest of this, and then we'll cover 5, 4. Okay? Well, we'll stop. Thank you, guys.
And we have that one worksheet due next time, right?